Welcome to Thriving Academy. Today we'll be looking at an example under pressure drop, how to calculate pressure drop along your oil pipeline. Now today's question is, let's look at this example. Today's question is, oil flows at 3 gallons per minute through a horizontal 0.75 inch internal diameter pipe for 10 feet length and pass through a 90-degree elbow into a vertical pipe which drops for 12 feet and passes through a second 90-degree elbow into a horizontal pipe for another 14 feet. The oil density is 54 pounds per cubic feet and viscosity of 75 centimeters. Coefficient of 90-degree elbow K is 0.75. If the initial pressure is 900 psi, what is the final pressure? So, when you are given a question to solve, the first thing to do is to analyze the question. So let's analyze this question together. The question says, oil flows at 3 gallons per minute through a horizontal 0.75 inch internal diameter pipe. A horizontal 0.75 inch internal diameter pipe. Now let's analyze the question. This one says oil flows through the horizontal. That means the pipe is something like this. Okay, the horizontal is something like this. The diameter is 0.75 internal diameter, and the distance from here, the distance from here to here is 0.75 internal, 0.75 inch. So the oil is flowing towards this direction. Internal diameter pipe for 10 feet length. They said the length of the pipe is 10 feet and the distance from here to here is 10 feet. Then it says, and pass through a 90-degree elbow. A 90-degree elbow, you know that 90-degree elbow is something like this. 90-degree elbow, something like this. And we should line at 90 degrees. So something like this. So at this point here, the pipe have a 90-degree elbow into a vertical pipe. Into a vertical pipe. So the pipe drops down and enter the vertical pipe. And enter the vertical pipe, which drops for 12 feet. Which drops for 12 feet and passes through a second 90-degree elbow into the horizontal pipe. So the vertical pipe drops for 12 feet. And the distance from here to here is 12 feet. So here it becomes 12 feet. Then pass to another second 90-degree elbow into the horizontal pipe for another 14 feet. So another horizontal pipe for another 14 feet. So the distance from here to here is 14 feet. Is 14 feet. For another 14 feet. Now I said, the oil density is this and viscosity is this. That means the oil is flowing through the horizontal pipe, then continuing in this process here, then flows towards this direction. So this becomes the analysis of this question. Now if you look at this, they gave us 1, 2, 3. They gave us 3 lengths. They gave us 3 lengths, 1, 2, and 3. With one particular one, diameter 0.75. So therefore, let's get the total length here. Let's sum this 1, 2, 3 length. So therefore, the total length, let's call it length over. So the total length, NT, which represents length over equal to his first length here, 10 feet. LT will be equal to sum of all the three lengths, which is equal to 10 feet plus 12 feet plus 14 feet. So everything here will give us what? 36 feet. So therefore, the length total is equal to 36 feet. This becomes the length total. Now let's write out the given parameters from the question. Oil flows at 3 gallons per minute through a horizontal 0.75 inch diameter pipe. They gave us the flow rate of the at which the oil is flowing. So Q here is equal to 3 gallons per minute. Let's start the given parameters. We said the flow rate is 3 gallons per minute, and we also have to convert it to what? Cubic feet per second, because that is the unit of flow rate. The next thing that they gave us is what? The diameter of the pipe is 0.75 inch. So therefore, diameter D here is equal to 0.75 inch. Also, they gave us the length of the pipe, which has already calculated here. Through a 90-degree angle, the vertical pipe draws for 10 feet, I've already put it here. The horizontal conversion. They gave us the oil density, which is 54 pounds per cubic feet. So oil density, let's call it rho, which is the same thing as specific weight, is equal to 54 pounds per cubic feet. Then also they gave us the viscosity of the oil at 75 centimeters. They gave us viscosity is equal to 75 centimeters. Then they gave us the coefficient of the 90-degree angle K. They said K is equal to 0.75. If the initial pressure is 900 psi, they gave us P1. They said P1 is equal to 900 psi. What is the final pressure? P2. So we are looking for P2. Cubic feet per second. How do you convert from gallon per minute to cubic feet per second? We said that 1 gallon is equal to 231 inch cube, and also 1 feet is equal to 12 inch. So therefore, let's convert flow rate equal to 3 gallons per minute to cubic feet per second. Let's go. This becomes multiplied by, since gallon is here, you have to divide by what? 1 gallon. So times 1 gallon. Then multiply by, now we are converting from gallon to feet, but we have to convert to inch cube. So it becomes multiplied by what? 231 inch cube, which becomes 231 inch cube. So that gallon, we're able to cancel that gallon. Then convert from inch now to what? To feet, so it becomes divide by 6 inches here. Here becomes what? 1. We said is 1 feet is equal to 12 feet, so it becomes what? 12 inch. Then now converting to feet here becomes what? 1 feet. But the inch here is cube. We won't be able to cancel this one here. So therefore, we cube everything here, so that here will become this equal of what? 3. So we cube this. So if we expand, this will give us 3 also. So also we are converting to per second too, and also here is what? 1 minute. We also said that 1 minute is equal to 60 seconds. So this becomes multiplied by 6 minutes is here, then becomes what? 1 minute divided by 60 seconds. So that minute will be able to cancel out minutes. So therefore, let's open bracket. This will give us Q here will be able to, Q here will give us 3 multiplied by 231 inch cube. 231 inch raised to the power of 3 times. Here now, let's open this bracket here. It will give us 1 feet raised to the power of 3 divided by 12 raised to the power of 3 inch raised to the power of 3. So that inch raised to the power of 3 will cancel out inch raised to the power of 3. Multiplied by 1 all over 60 seconds. So our flow rate Q is equal to 3 times 231. This is the value divided by 12 raised to the power of 3 times what? 60. What will be the unit now? Feet raised to the power of 3 divided by what? Second. Divided by second. Close the bracket here. Complete this. Our flow rate Q here. Flow rate Q will be equal to 0.00664. Feet raised to the power of 3 per second. So our flow rate. This becomes our flow rate. Now that we have our flow rate, let's calculate for the area of the pipe. Recall that for the calculation of area is equal to pi d squared divided by 4. The diameter is given to us as 0.75 and it is in inches and our flow rate is in what? Feet raised to the power of 3. So you have to convert the diameter from inch now to feet. How do you convert from inch to feet? You say that 1 feet here is equal to 12 inch. So therefore, diameter equal to 0.75 inch here. 0.75 inch will be equal to 0.75 inch multiplied by 12 inch. Then it becomes 1. Such that inch will be able to cancel out inch. If you have problem in your conversion, please do well to watch our conversion video. So therefore, our diameter here will be equal to 0.75 divided by 12 feet. If you do this, diameter G will be equal to 0.0625 feet. So therefore, we have successfully convert our flow rate from gallon per minute to 50 feet per second and our diameter from inch to feet. Now that we have the diameter of our pipe in feet, remember they gave us the diameter in inches, which is 0.75, and then we converted it to feet, which is 0.0625 feet. And also our flow rate was given to us in gallon per minute, and then we converted it to cubic feet per second. So now let's apply for the area of the pipe. How do you calculate for area? We said area is equal to pi d squared over 4, where pi is equal to 3.14. So therefore, let's calculate for our area. Our area of the pipe will be equal to pi d squared divided by 4, where pi is equal to 3.14. Let's substitute values. If we substitute value, our area will be equal to 3.14 all in bracket. Our diameter is 0.0625 in bracket. Is a feet all in square divided by 4. So therefore our area will be equal to, compute this, we are going to have area as 0.0036664. The unit of area is in feet square. So if you compute this, you have area is equal to what? This value. Square feet here becomes what? Square. That is how you calculate for your area. Now let's dive into what? Our calculation. First step, calculate the velocity. Now remember that on one of our classes we said that velocity V is equal to flow rate divided by area. Now we have our flow rate, yes, we have our area, yes, so therefore let's substitute value. We substitute value, our velocity will be equal to flow rate, which is equal to 0.006684 feet cube per second divided by area. Our area is 0.03664. 0.03664. What is the unit? Feet square. Sorry. Here is area is 1.0030664. So if you punch this, our velocity V will be equal to 2.18 feet here. Feet here will cancel 2 feet from here. We left with 1 then. Second, so our velocity will be equal to feet per second. So these are you calculate for your velocity. Step 2, calculate for your what? Reynolds number. Step 2, Reynolds number. Now what is the formula for Reynolds number? We said that the formula for Reynolds number depends on the unit of the diameter. In this case now, our diameter is 0.75 inch. So therefore, since diameter is the inch, our Reynolds number formula becomes NROP is equal to 7747 multiplied by the specific gravity multiplied by V multiplied by what? G. All divided by the viscosity of the fluid. But in this case now, he didn't give us specific gravity. No, so how do you get specific gravity? There are two ways of getting specific gravity. But we are going to pause. So, specific gravity times velocity times z over v. Specific gravity is not neutral, but they gave us what? Density. Can we calculate for specific gravity from density? Yes. But also, if you look at this, our viscosity was given to us, but it is the what? Centistools. And this viscosity here is a centipoise. So how do you convert from centistool to centipoise? We said that 1 centipoise is equal to centistool multiplied by specific gravity. In this case now, we can simply say that our mu will be equal to 75 multiplied by the specific gravity. Remember, they gave us the viscosity intensity, which is what? 75 times specific gravity, which is not given. So, I can say that our is equal to 75 times what? Specific gravity. If we substitute inside the formula, also note that the diameter here is the what? Inch and not in feet. So, therefore, let's decide the Reynolds number formula. Our NRO Reynolds number will be equal to 7740 multiplied by specific gravity, which is unknown. Let's put specific gravity is unknown. Multiplied by velocity. What is our velocity? 2.18 here becomes 2.18. Multiplied by what? Diameter in inch. Our diameter in inch is 0.75. So here becomes 0.75. All divided by our viscosity mu. We said that mu is equal to centrifugal times specific gravity, which is 75 times specific gravity, which is equal to 75 times specific gravity. Specific gravity will cancel specific gravity. Our NRO Reynolds number will be equal to 7740 multiplied by 2.18 multiplied by 0.75, all divided by 75. So therefore, our NRO will be equal to 168.732. That's how it is. Remember, we said that our NRO determines the type of flow in the pipe. In this case now, our NRO Reynolds number is 168.73. We state the condition for laminar and turbulent flow. But here, since our NRO is 168.73, we can simply say that it is a what? A laminar flow, because the Reynolds number is less than what? 2000. So therefore, since our Reynolds number is lesser than 2000, the flow is laminar. The flow is laminar. Laminar flow, we said that laminar flow has its own friction factor formula, and turbulent flow has its own friction factor formula. Now, for laminar flow, we said that the friction factor F is equal to 64 divided by Reynolds number. So therefore, our F will be equal to 64 divided by Reynolds number. What is Reynolds number? 168.732. 168.732. So this will give us 0.379. If you calculate for the friction factor, we have 0.379. So therefore, now that we have our friction factor, we can simply calculate for our head loss. Remember the head loss formula. Step 3. Calculate for head loss. Calculate for head loss. We said that head loss, H area, is equal to the friction loss multiplied by the length of the pipe multiplied by V squared, all divided by 2dg. All divided by 2dg. Now if you look at this is our pipe. Our pipe has 3 different lengths. We said that the total length of the pipe is equal to 10 plus 12 plus 14, which is equal to 36. But there is a what? Elevation. They gave us an elevation because at this point there is a vertical height, which is what? 12 feet. Let's analyze the height of this question before we calculate for the length. If you look at this question very well, the flow started through a horizontal pipe. So at the beginning of the pipe, there is no elevation. You can simply say that if Z, the elevation at the beginning of this pipe here, which is Z1, is equal to 0 because there is no what? Elevation. Then when going at the point, the pipe, the flow is deviated into a what? A 90-degree vertical pipe. Deviated, remember the flow is going downward. So it deviated into a 90-degree vertical pipe. I simply call it Z2. At the beginning there was no elevation, so there is no Z1, it is Z1. At the center there is an elevation, so let's call it what? Z2, which is equal to, it is what? 12, the height of the pipe is elevation, which is what? 12 feet. But if you look at the direction of the flow is going downward. And we said that when the flow is going upward, the elevation becomes positive, and when the flow is going downward, the elevation becomes what? Negative. In this case now, since the flow is going downward, our Z2, which is 12 feet, becomes what? Negative. It is negative because the flow is going downward. So therefore, Z2 becomes what? Minus 12 feet. Minus 12 feet. Then, to get the length for this calculation, you can simply use this equation. Length of the pipe is equal to the total length plus the pipe roughness also. To get the length there now, since our pipe is horizontal, vertical, and horizontal again, let's get the length. Now to get the length of that pipe now, it becomes the total length of the pipe plus 2kg divided by the friction factor. So this will give us our length is equal to, this LT is the total length of the pipe, 2, this K here is the coefficient for 90-degree heaven, and it's given to us as 0.75. Then the D here is the diameter of our pipe. It is a feet. So therefore, if we substitute, our total length is 36 feet plus 2. Our K is given to us as 0.75 is given to us, and our D is in feet. And if we said our D is 0.0625 in feet, so this gives us 0.0625. All divided by friction factor. Our friction factor is 0.379. So this becomes 0.379. So therefore, our length will be equal to 36.25 feet. After so we have 36.25 feet. So therefore, we can simply calculate for our head loss. So therefore, we can simply say that head loss is equal to friction factor, which is 0.379 multiplied by the length. The length of our pipe is 36.25. So this becomes 36.25. Then multiplied by the velocity square. Our velocity is 2.18, so it becomes 2.18 all in bracket square divided by 2 into D. Our diameter is in feet, which is 0.0625. Then our G is the first hand. G is always the first hand, and G is equal to 32.2 feet per second. So we can simply say that this is into 32.2 feet per second. So therefore, our head loss after calculating will be equal to 16.2 feet. So this is the head loss for this equation. Now the question says, what is our P2? We are not calculating for head loss, rather we are calculating for P2. So therefore, The next step now, step 4, is to calculate for what P2 using your Bernoulli. The equation says we should calculate for our P2. They gave us P1 as 900 psi. Let's calculate for P2. Now, if you look at this question here, we cannot use the head loss to multiply by the density to get our delta P, which is our current law, because they gave us what an elevation in the question, which is what minus 12 feet, which they gave us elevation. Remember, you can only use your head loss to multiply the density when elevation is not given. But in this case, now they gave us elevation. How do you use Bernoulli's equation to calculate for your P2? Recall Bernoulli's equation. For Bernoulli's equation, we said that is, recall that Z1 plus P1 divided by specific weight plus V1 squared divided by 2G plus HE minus HM minus HL is equal to Z2 plus P2 divided by specific weight plus V2 squared divided by 2G. Now, in this particular question, let's compare parameters to the Bernoulli's equation formula. They gave us Z1 as 0. So Z1 is 0. They gave us as 0. They gave us P1 as 900 psi, that is 16. They gave us specific weight, which is our density, as 4 pounds per cubic feet. They then give us V1, velocity at the pipe 1 is not given. So this one is out. They did not give us pump head, so this one too is out because it is 0. Motor head also was not given, so we assume that it's 0. These ones that are not given, we assume that they are 0, so they are out. Head loss, we have calculated for head loss as 16.2 feet, so therefore we have head loss. The Z2 was given from the diagram. We said that Z2 is elevation, which is what? Minus 12 feet, which is negative because the flow is going down. So Z2 is minus 12 feet given. Then P2, we are looking for P2. Specific weight is given as 54 pounds per cubic feet. Then V2 is not given, so we assume that it is 0, so this one is out. So therefore, our Bernoulli's equation can be write as Z1 plus U1 divided by specific weight minus head loss is equal to Z2 plus P2 divided by specific weight. Now this becomes the Bernoulli's equation that we will use to find what? P2. Let's do two parameters. Z1 is equal to 0. So therefore, let's substitute parameter. Or let's make P2 subject of formula from here. To make P2 subject of formula, make P2 subject of formula. To make P2 subject of formula, to be negative, so such that P2 divided by specific weight will be equal to Z2 plus this becomes negative. So to give us Z1 minus Z2 crosses to this other side becomes negative plus U1 over specific weight minus head loss. So therefore, if we write this equation, put head loss at this point here, we're going to have P2 divided by specific weight that will be equal to Z1 minus Z2 minus, take this one first, that's minus head loss, then plus P1 divided by specific weight. Now P2, we are interested in making P2 solid of formula. So therefore, multiply through by specific weight becomes multiply specific weight we multiply this other side here, so that our P2 here will be equal to specific weight into Z1 minus Z2 minus head loss, then plus specific weight into P1 over this. Remember that specific weight is multiplying everything here. So because multiply this one and multiply this, which is this. So therefore, our P2 here will be equal to specific weight into Z1 minus Z2 minus head loss. Specific weight will cancel that specific weight here. It becomes plus P1 plus P1. So therefore, let's substitute values. Start. Substitute values into this thing now. Our P2 will be equal to our specific weight, which was given to us in the question as 54 pounds per cubic feet. So consider P2 is equal to 54. Substituting values, our specific weight is 54 pounds per cubic feet into 0. As Z1 it is 0, then minus. Our Z2 is minus 12. 12 becomes minus 12 feet. Then minus, which is this minus. Our head loss is 16.2 feet. 16.2 feet. Close the bracket. Then plus P1, which is what? 900 psi. So this will give us P2 will be equal to 54 pounds per cubic feet into 0 is at minus times minus plus will give us 12 feet minus 16.2 feet. Close the bracket plus 900 psi. 900 psi. So this will give us P2 will be equal to 54 pounds per cubic feet into 12 feet minus 16.2 feet will give us minus 4.2 feet. Minus 4.2 feet plus 900 psi. Feet here will cancel one foot from there. This will give us P2 equal to 54 times minus 4.2 will give us 200 minus 200 minus 226.8 minus 226.8 pounds per foot square. Note that feet here cancel out foot from here. So pounds per foot square plus 900 psi. Now, P2 now will be equal to minus 226.8 pounds. Remember, 900 psi. Psi in full is what? Pounds per square what? Inch. So therefore, psi in pounds per square inch. So therefore, we have to convert from pounds per square feet to pounds per square inch. To convert to that, we have to convert the feet here, the feet square here to inch square. So therefore, this becomes pounds per feet square. Convert the feet square to inch square. So it will be pounds per square inch. Becomes multiplied by. We are trying to convert from feet to what? Inch here. So in this case now, since feet here is at the denominator, it will become at the numerator. In such a way that feet can cancel what? Feet. Then divided by. Remember we said that 1 foot is equal to 12 inches. So therefore divide by 1 feet, then divide by 12 inches. But the feet here is square. For us to get feet square now, we have to square everything here plus 900 psi. Remember that we are doing this now so that psi, here will be psi, also here will be psi, pounds per square inch. So therefore, our P2 will be equal to minus 226.8 pounds per feet square multiplied by, open this bracket to give us feet square, 1 foot square divided by 12 square inch square plus 900 psi. So this will give us feet here will cancel feet square here. So this will give us P2 will be equal to minus 226.8 pounds divided by 12 square pounds per watt. Remember, each cancel as well left with us inch square. It's from pounds per inch square plus 900. Write psi in the symbol form, it comes from pounds per watt inch square. So if you divide this, P2 will be equal to minus 1.575 pounds per inch square plus 900 pounds per inch square. So P2 here, add these two together, P2 is equal to 88.4 pounds per inch square. So therefore, P2 is equal to 88.4 psi, pounds per square inch. So this becomes the answer. So this is how you calculate this sort of question on product using Bernoulli's equation. Thank you.